In this video, I'm going to talk about homologous series. If this is the first time watching my video or coming across this channel, don't forget to like, share, and subscribe. And at the same time, make sure you drop a comment in the comment section below. Then, if you haven't watched my previous video on hydrocarbon, alkane, and alkyne, do wait to pause this video right now and go back and watch it because they will serve as, let me say, basic knowledge to this homologous series. Now, what are homologous series? They are basically group of compound. We can call them group of compound, or you simply say family of compound, of organic compound, right? Let me just use the word family because it's kind of it's making sense. Family of what? Of organic compound. I'm going to represent as what? As OC, or you simply say group of organic compound, and then they have the same functional group or true. Homologous series, they are compounds, family of compound. You understand? That is compound that belongs to the same family and they have the same functional group. So in that case, whenever they have the same functional group, that shows that they are going to have the same chemical properties. Are you getting it now? So when it comes to homologous series, they have the same chemical properties all through. That is all the compound belonging to that particular compound, to that compound belonging to that particular family. They have the same chemical properties, but the physical properties is different. And I'm going to explain the reason why the physical properties is different in a moment. Right now, one thing about homologous series is that they are actually used in organic chemistry to actually classify and identify organic compound. To classify organic compound and identify the function of an organic compound. That's basically when homologous series is actually what's used. So they are family of organic compound that belongs to the same functional group. They have the same functional group, and in that case, since they are having the same functional group, they are going to have the same chemical properties. They will undergo the same chemical reaction, unlike the physical properties. The physical properties is going to be different based on the number of carbon-to-carbon atoms that are present. And don't forget, let me just simply recall, let me bring them out. If you have carbon number 1, we basically call it as what? As met, right? If you have 2 carbon, right, we call it what? X, right? If you have 3 carbon atom, we call it what? Probe, right? And if we have 4 carbon atom, this is going to be what? Boot. If you have 5 carbon atom, this is going to be we are going to have it to be pent. It is going to be pent, not X. It's going to be pent. So this is going to be pent. And if you have 6 carbon atom, this is basically X. If you have 7 carbon atom, this is going to be X, right? And if you have 8 carbon atom, this is going to be oct. Then if you have 9 carbon atom, this is going to be none, right? And if you have 10, this basically represents dec, right? So if you look at this very well, so there is actually increase in the number of carbon atom, right? There is increased number of carbon atom. Look at this. We have 1 carbon atom. Carbon, in that case, this is going to have, it's going to be 12 grams, right? Because generally, carbon has the mass of 12. So that's 12 grams. The molecular weight of any compound, of any hydrocarbon or compound that contains just a single carbon atom, that's going to be 12. That is, it is 12 because it contains the carbon. The weight of carbon is what is 12. Here, the weight of carbon is going to be 24. And the weight of carbon here is going to be 36. And if you look at this, there is actually increase, right? There is increase in the molecular weight. So that's actually what contributes to the different physical properties. That's basically the reason why the homologous series, they have different physical properties because their molecular weight is not the same. As the number of carbon atom increases, the molecular weight is also going to increase, as you can see. When it is 1 carbon atom, we have it to be 12. When it is 2 carbon atom, we have it to be 24. When it is 3 carbon atom, we have it to be 36. When it is 4 carbon atom, it's going to be 48. When it is 5 carbon atom, it's going to be what? It's going to be 60. So there is increase in the molecular weight, and whenever there is increase in molecular weight, there will be change in the density, right? The density is going to be different, and at the same time, the boiling and the melting point is going to be different. So basically, whenever there is increase in the number of carbon atom down the homologous series, the boiling point and the melting point is also going to increase, right? Increase the number of carbon atom, we increase the boiling and the melting point, and at the same time, whenever there is increase in the molecular weight, right, from 12 to 24, from 24 to 36, definitely there's going to be increase in the density as well. So the density of this compound also increases down the homologous series. That's why we have what different physical property. They have different physical property. From carbon 1, 2, 3, and 4, they exist as what as or and 5 rather. They exist as what as gaseous at room temperature. From 6, 7 to 17, they exist as what as liquid. While from 18 downward, they are what? They are solid. So they have different physical states, and that simply means they have different physical property. But their chemical property what is the same, based on the functional group that is present. Alkane generally, they are made up of just a single double bond. Alkyne, they are what? Sorry, single bond. Alkyne, they are double bond, while alkyne, they are triple bond. Alkane is single bond, alkene is double bond, while alkyne are what? Alkynes are what? Triple bond. So this basically marks difference between what the behavior. Let me say, it's actually shows the difference between the behavior of the compound in a chemical reaction. So any family of hydrocarbon belonging to alkene, they are going to have the same chemical property. Any family of hydrocarbon belonging to alkene, they will have the same chemical properties. Any family of hydrocarbon belonging to alkyne, they are going to have the same chemical properties. So hydrocarbon basically, homologous series basically, they are family of organic compound that have the same functional group. Right? The number of carbon atoms might be different, which actually makes the physical property to be different. But since they are having the same functional group or two, they are going to have the same chemical properties. Right? So I'm going to talk about functional group in a separate video. But this is actually what I want you guys to understand when it comes to homologous series. So they are basically family of organic compound that have the same chemical properties but different physical properties. Why? Because of the functional group. Right? The functional group make them have the same chemical properties, but because of the number of carbon atoms that are present in those compounds, that's why they're going to have different physical properties, but same chemical properties. Now that's just about this video. If you enjoyed it, don't forget to like, share, and subscribe. It's very, very important. So in the next video, I'm going to talk about the functional group that we have. Thanks for watching.